Check it.
Okay, welcome back. Today we're going to pick up where we left off yesterday. We're going to be finishing up section 9.1, which is multiplying and dividing rational expressions and simplifying them as well. Let's just do two problems from the homework here just to kind of pick up where we left off. This is going to be a short lesson because I did almost everything yesterday. Okay, so for number 4 here, you want to simplify this, and you also want to give the domain of the expression. So, you know, the domain restrictions. So the first thing you're supposed to do with all of these is put them in fully factored form. And the top and the bottom both can be factored. So let's go ahead and factor the top and the bottom. So we have the top here looks like reverse FOIL is going to work because there's nothing in front of the y squared, right? There's a 1. So just put a y and a y. Two numbers that multiply to give me negative 40, they add to give me 3. What would that be, like 8 and 5, right? They have a separation of 3. The bigger number would be this sign here, which is positive, and this should be negative, okay? And that will work. Now the bottom is a difference of squares. Something squared minus something squared. And whenever you have a difference of squares, you can factor it as the square root of the first thing, 5, plus the square root of the second thing, y, and 5 minus y. So 5 plus y, 5 minus y. And once you have it fully factored, now you can find your domain constraints. So what are our domain constraints here? What are the y's that would cause a 0 denominator? Okay, numerator is fine. Numerator could be 0 all day long. It's the denominator that can't be 0. Well, you can see that if you had a negative 5 here for y, that would create a 5 minus 5, and that would make a 0. So no good. You can't have y equaling negative 5. And here, if you put a positive 5 here, 5 minus 5 would give you another 0. So that's no good. So y can't equal 5 either, okay? Y can't equal 5 or negative 5. Once you've done that, now you can cancel stuff out. But make sure you find your domain constraints before you cancel anything out, okay? Find your domain constraints. And basically that just means your domain is everything except these numbers, right? So your domain constraints is the same as saying your domain is all real numbers except this and this, y equals 5 and y equals negative 5. Now you look around and say, can I cancel anything out? And the answer is nothing is exactly the same, so nothing cancels out yet. But if you notice, these are really close. This is y minus 5, and this is 5 minus y. So they're almost the same, but they're backwards. One is backwards from the other, so compared to the other. So I showed you a trick yesterday that you can factor out a negative 1 to make these things flip around. Okay? And you can do it to the top or the bottom. So I'll just do it to the top. If you're going to do this to the top, what you can do is put a negative 1 out here, okay? And let me rewrite this here. So copy this. Let's put it right over here. Okay, we're going to put a negative 1 out here and then compensate for that by making this negative, put a negative 1 here, and this negative negative, which means positive here. Okay, we're only doing this to one factor. So basically what I'm doing is I'm factoring out a negative 1, and you can see that if I were to distribute that negative 1 back, this would become positive y and this would become negative 5. But once I do that, watch what happens now. Now I have y plus 8, which I didn't touch, and this is now negative y plus 5, which is the same as 5 minus y. So this is 5 minus y right here, over 5 plus y, and this is 5 minus y. So this is exactly the same. Now they're the same. Oops, forgot the negative 1 over here. Don't forget the negative 1. Or you know what? You don't need a negative 1. You just need a negative. Okay? That's the important thing. The 1 is superfluous. So anyway, this can now cancel out. Okay? And you only cancel stuff out after you find your domain constraints. So what do we have now? We have, let's do this down here. We have the negative, which is going to go in front of the fraction. We have the y plus 8 on the top, and we have the 5 plus y on the bottom. Okay, and let's take a look at the answer. Yep, there it is. Well, they wrote it as y plus 5 instead of 5 plus y, but that's the same thing. Okay? All right. And for a question like number 7 from last night's homework, this is a division question. What I told you yesterday was don't divide, multiply by the reciprocal. So the first thing you want to do is flip this upside down here. So no, the first one doesn't get flipped. I'm sorry, the second one gets flipped. So the first one remains as it is. The second one, you're going to turn this into multiplication and then flip this second fraction. So this is now 26b on top. And this is 36xy cubed on the bottom. And before you multiply, okay, once again, the idea is to avoid reaching for a calculator here. Multiplying 12 times 26 or 13 times 36, they're all big numbers. So we want to simplify before we multiply. Because if you multiply these, you're going to have huge numbers that are going to be hard to reduce. And you have to reduce. It's not optional. So let's take a look and see if we can cross cancel, okay? Now this is actually supposed to be today's lesson, but I taught it yesterday, so today's lesson is going to be extra short. All right, so what you do is you look on the top on one fraction and on the bottom on the other fraction and see if you can cancel anything out, okay? So let's see. We definitely, let me zoom in here so you can get a really nice look at this. We have a 12 here, and we have a 36 here, which is just 12 times 3. So you can cancel out a 12. If I cancel out this 12 from here, and I cancel out a 12 from here, what's left is a 3, right? Because this is 3 times 12, right? This is 3 times 12, and I'm canceling out the 12. All right? Now, I also have an x cubed up here and an x down here. What they have in common, what I can factor out of both of them, is a single x. So cancel out an x from here, and that'll cancel out one of the x's here. Now, there's 3 of them, so this becomes x squared. I also have a y here and 3 y's here, not 3y, but y to the third power. So I can cancel out, factor out and cancel out one y here, and that'll leave me with a y squared down here. Okay? So I've gotten rid of this 36 and made it a 3. I've gotten rid of this 12 altogether. My numbers are getting smaller, and I'm not going to have to multiply 12 times 26 or 13 times 36. How about going this way now? Going this way, cross-canceling. I have a 13 and a 26. Well, isn't 26 just 13 times 2? So if I factor and cancel out a 13 from here and a 13 from here, all that's left now is just a 2. I also have an a here, but there's no a here to cancel out. I have a b squared here and a b here. So out of these two, I can factor out a single b. So I'll cancel out a b here, and one of the b's here, so that's gone. And now I have a much simpler thing to multiply now. So this becomes, the 12 is gone, I have an x squared. I'll rewrite it even though you don't really have to. Have an x squared, and that's it. There's nothing else that survived over here. And on the bottom, I just have an ab. Times, remember this is times now. Nothing survived here but the 2, right? The b is gone, the 26 is gone, just the 2. And on the bottom here, just a 3y squared. And that's what you're going to multiply. So x squared times 2 is 2x squared. And down here, ab times 3y squared is alphabetically, you start with the number, 3aby squared. And then you double check before you box your answer. Can I simplify? If this was if this was a 6, for instance, let's just argument's sake. Let's say that was a 6, then you could reduce that. But 2 over 3 is already reduced, and there's nothing else to cancel out here. So we'll check the answer here. And yep, there it is. Same thing. Okay. All right. So that was 2 problems from yesterday's homework. Some notes here on cross canceling. Let's just do a couple of examples here, and then we'll move on to the last thing. Okay, so this is a bunch of stuff that's not factored. Okay, the first step for all of these questions is put things into fully factored form. Okay, so that's what you need. Factor anything that can possibly be factored. That can be factored. Okay, so FFF all the way here, fully factored form. Factor everything. So let's take a look. We have a fraction here. The fraction has a numerator that's a quadratic, so looks like an easy factoring job. It looks like reverse FOIL because there's nothing in front of the x. If there was like a 2 here, we'd have to use, well, actually, that would be a GCF. If there was a 5 here, for instance, we have to use AC method, but this is good enough. This is an x and this is an x. 2 numbers that multiply to give me 16, they add to give me 2. 8 and 2. Sorry, add to give me 6 rather. 8 and 2. Right? They're separated by 6. The negative is the bigger number, so negative in front of the 8 and a positive in front of the 2. So that's going to work. Down here, also reverse FOIL. Okay? Looks actually like a perfect square trinomial here. we have two numbers that multiply to give me 64, but add to give me negative 6. It looks like negative 8 and negative 8. So it's a square of x minus 8. So that's factored, okay, from way back in earlier in the year. Now, what about up here? This right here, okay, is already a single factor, so no need to factor that. You could put parentheses around if you feel better, but you don't need to. And then this definitely is factorable here. Okay, x and x. Two numbers that multiply to give me 6 that add to give me 5 are 2 and 3. Looks like they're both positive. Okay, so now we're in fully factored form. Okay, now if, and this is not one of those questions where they say find the domain constraints, but we can if we need to. What are the numbers you cannot plug into any of these fractions here? Well, you definitely can't plug in an 8 because 8 would create a 0 here. 8 minus 8, 8 minus 8. You definitely can't plug in a negative 2. So x cannot equal 8, x cannot equal negative 2, and x cannot equal negative 3. Those are the domain constraints if this were a function. It's not a function, so we don't have to worry about that. But just letting you know, that's how you would do that. You would set each one of these equal to 0, and that would give you 8. And you'd set this equal to 0, and that would give you negative 2. And you set this equal to 0, and that would give you negative 3. But they're not asking you to do that for this particular problem. But it's good to be able to know how to do that. Anyway, once you have your domain constraints, I'll tell you what, let's just do that anyway. Let's just pretend they did ask us, or they did put an f of x equals in front of this function, and let's pretend that we needed to do that. So there you go. If you needed to do that, there it is right there. Now, once you find your domain constraints, you can start canceling stuff out. Okay? And you can cross cancel like we did a minute ago. You can also cancel within the same fraction. So take a look at this. Within the same fraction, there are two things that cancel out. So you can do that within the same fraction or cross-canceling. So within the same fraction, we'll cancel those out. But then cross-canceling, look at that. You have an x minus 8 and x minus 8 here. So cancel that and cancel that. And then cross-canceling this way, you got an x plus 2 and x plus 2. Cancel that and cancel out. We've canceled out everything here. This is gone. This entire fraction is getting canceled out. And nothing is left on the top of this fraction, so that's a 1. Okay? Because how do you cancel? You have something over itself, which is 1, right? So it's not really canceling, it's just becoming 1s. And the only thing that survives on the bottom is x plus 3. So if this were a function, let's call this f of x equals, then our f of x would be, after simplifying it, would be 1 over x plus 3, but then you would also have this domain constraint that x cannot equal 8 or negative 2 or negative 3. Okay? Now, they didn't put the f of x equals 2, so they didn't really we didn't have to do that part there, but I just wanted to kill two birds with one stone there. Show you how to do that, just in case you were still foggy on it. Okay, this next question down here is the same kind of question, but there are two letters, x and y, so you definitely are not going to find any domain constraints on this one because there's two different letters, and you can't do it with two letters. And it's a division problem, so we're going to not divide, we're going to multiply by the reciprocal. So let's go ahead and do that. Matter of fact, let's save a step by factoring as we go. So this is going to be something times something, okay? And let's go ahead and factor. So that if you could see the, what do you call it? This right here is a difference of squares. And it's going to be x plus 4 and x minus 4. So let's go right to that. Save a little time. I'd like this video to be shorter than yesterday's. Down here, it looks like there's nothing to factor because it's linear, but there is a GCF here. There is a 12 that you can pull out of both of this and both this term and this term. So we can pull the 12 out, and what's left is y plus 3. Okay, like I say, fully factored form. Factor everything that can be factored, including GCFs. Now, we're going to flip this and multiply. Flip and multiply. Okay, so I'm going to take the bottom of this and put it on the top here, and I'm going to factor it. And it looks like reverse FOIL should do the trick here. Y, two numbers that multiply to give me 18 and add to give me, what do they call it? It's going to be 6 and 3, right? And let's see, the 6 is going to be negative, the 3 is going to be positive. If you double check that, that does work. And now the top one here becomes the bottom one here. Okay, so just in case you're reading this later, this has been flipped. All right, so this is going to be x and x. Two numbers that multiply give me 32, that add to give me 12, 8 and 4, right? The bigger number is negative. And because the last number here is, the last sign here is positive, it must mean both of these are negative. Okay, and you can double check that. Negative 8 times negative 4 is positive 32. Negative 8 plus negative 4 is negative 12. So that works there. Okay, we're not going to find domain constraints because there's 2 letters in here, so you can't do that. But we can start simplifying. Now, look within the fraction. Is there anything to cancel in here? No. Anything to cancel in here? No. Anything to cross cancel? Yes. X minus 4 will cross cancel with X minus 4. Y plus 3 will cross cancel with Y plus 3. So that's cross canceling. And now we can just put together our answer here. So X plus 4 and then Y minus 6. Those are the survivors there. And down at the bottom, 12 times X minus 8. Okay? So I'm not going to ask you to multiply things back out. So, if I ask you to FOIL the top or simplify the top, I'll ask you to do that later. But right now, leave the top alone. And the bottom, I'm never going to ask you to to multiply out. The bottom is always better factored. So leave the bottom factored. Okay. So I don't even know if I have an answer here. No, I don't, but it's correct. Okay, this last part here. Okay, so let's take a look at the time here. I'm 16 minutes in and I'm almost done. So a lot shorter than yesterday. Simplifying compound fractions, or in the book they call them complex fractions. A compound fraction is a fraction within a fraction. Okay, here's an example. This is a compound fraction. Okay, and what do you do when you see something like that? And the answer is, well, don't forget, a fraction is just division. Okay, the top divided by the bottom. So this is the same as saying the top fraction divided by the bottom fraction. And I've told you, don't divide, multiply by the reciprocal. So that just means the first one times the reciprocal of the second one. Oop, that's a b squared. That's all that means. And then from there, take it away. Okay? So not a big deal. If you see a compound fraction, take the top and multiply it by the reciprocal of the bottom, the upside down version of the bottom. And that's it. So let's go ahead and do that. So remember, fully factored form first. Okay, quadruple F that time. This is fully factored, that's fully factored, nothing you can do there. This is fully factored, and this is a sum of squares. Can you factor a sum of squares? No. Difference of squares? Yes. Sum of squares? No. So this isn't factorable. So, you might have thought, hey, this is a plus b times a plus b. No, it's not. So the only thing we can factor here, cancel rather, cross cancel are the 4's. And what we get is a plus b on top, a squared plus b squared on the bottom, and we're done. Okay? Complex fractions, not so complex, not so hard. Okay? Let's try like a couple more examples and we will call it a day. All right, that's it right there. So here we go. Once again, big, scary, complex fractions, a quadruple decker, right? Not a problem. Take the top, write it down. Okay? Take the bottom, flip it, and multiply by the flip of that. So this is going to be 4x minus 10 on top, and it'll be x squared minus 4 on the bottom. Okay, so now let's fully factor this. I'm going to expand this here so that it becomes x minus 2 twice. That'll come in handy in a minute. This is a 2, that's a factor out there. And this here can be factored with reverse FOIL. Luckily, everything in the section seems to be reverse FOILable. So that's x, that's x. 2 numbers that multiply to give you 4 that add to give you negative 5. Well, 4 and 1 will give you a 5. And if they're both negative, when you add them, you get a negative 5. So if you check that, that'll work. Here we have, times. And here we have 4x minus 10, which is a linear factor. So it's not something you can factor into 2 factors. But there's a GCF in there. There's a 2. And if you pull the 2 out, what's left? Well, you get 2x minus 5. Right? If you pull a 2 out of here, 2 out of here, you get that. This down here is a difference of squares, so this becomes x plus 2, x minus 2. Okay? If I'm moving too quickly, this is YouTube. You can always put me on 0.5 or rewind as much as you like. That might be funny, actually, 0.5. All right, so anyway, we're not going to do the domain thing here, so we're just going to look to see what will cancel out. This will cancel out. this will cancel out, this 2 will cancel out, and this 2 will cancel out. And what survives? The x minus 2 and the 2x minus 5. So x minus 2, 2x minus 5 on top. And on the bottom, these three terms, x minus 4, x minus 1, and x plus 2. Okay. And I'm going to leave it in fully factored form. And you can see up here, they do the same thing. They left it in fully factored form. So don't worry about multiplying any of this stuff out. Definitely never the denominators. The tops once in a while, but not for now. Okay, last question. We're going to call it a day. We have this one over here. So once again, you have a compound fraction. Take the top and multiply it by the reciprocal of the bottom. Don't be scared by the fact that it's a four level fraction. So here we go. X squared minus y squared over y squared minus 49 times the reciprocal of this, which is now going to be y plus 7 on top and y minus x on the bottom. This is flipped. Okay, in case you're reading this later. All right. So this is a difference of squares right here. We need to go to fully factored form, right? This is a difference of squares, x squared minus y squared. So this will be x plus y, x minus y. X minus y. Difference of squares, always great. Y squared minus 49. Actually, another difference of square. This is y squared minus 7 squared. So y plus 7, y minus 7. The easiest factoring jobs are always differences of squares. And now here we have times, and we have this stuff is already factored. This is y plus 7. You can't factor that. There's no GCF. And this is y minus x. Okay? So we're not going to do any kind of domain here because once again there's x's and y's and they're not asking us to. But let's see, anything cancel? Yeah, there's a y plus 7 here that will cross cancel with this y plus 7 here. There's a y minus 7 here which will not cancel with anything here. There's a y minus x here, and there's an x minus y here. So maybe you think you can't cross cancel, but what if I were to rewrite this as negative 1 times, and then you can flip this. It's because negative y and positive x. So this becomes x minus y. That's that trick that I showed you where if you pull out a negative 1, you can flip this. You can switch the places. So if I do that, now suddenly, hey, I can actually cancel out this x minus y here with this x minus y here. So all that's left here is a negative 1. Okay? And now let's finish our answer here. The only thing that survives on the top is x plus y. On the bottom, we have a negative 1, which I'll put first. And then we have a y minus 7. And we'll simplify that. This is x plus y. What's the negative 1 going to do to the y minus 7? It'll flip it around, just like we learned. So it becomes 7 minus y. And that's it. There you go. If you want to see how that works, negative 1 times y is going to be negative y, and negative 1 times negative 7 will give you positive 7. So you see that does work. Let's check our answer. And there it is. Well, actually, okay. It's a little different only because what they did, okay, let me take their answer here, and I'm going to make it look like my answer without doing anything illegal, okay? You can see there's a negative on both of these, right? So if you can factor out that negative 1, you will now have x plus y. And if you factor out a negative 1 from the bottom here, you'll flip these around, and this becomes 7 minus y instead of y minus 7. And if you cancel out those two negative 1s, you'll get the answer that I have down here. So my answer is correct, but theirs is just flipped around because they didn't factor out their negative y's. Okay, this is kind of odd. But anyway, there it goes. All right, these are equivalent actually. So I would take either one on a quiz. Okay, we're done. Have a good one.
Check this.